If the tire of a car has a diameter of 2.3 feet and the tire is rotating at a rate of 1,000 revolutions per minute or RPM, what is the linear speed of the car? Here I'm going to draw a little visual model first. So there's the road. There's the tire. There's the center of the tire. And there's the radius of the tire. Now the tire meets the road right here. And let's say that the car is going in this direction, forward. That means the tire is going to have to be rotating this way. And in one revolution, where the tire meets the road, we'll have moved over to, say, let's say right here. And this distance is the circumference, which is 2 times pi times the radius. So for each rotation of the tire, the car moves forward 1 circumference of the circle. Now what that means for us is that the linear speed of the tire is equal to the linear speed of the car. So when it asks for the linear speed of the car, really we just need to know the linear speed of the tire. And the only exception is, let's say the car is going from a start and the tire is spinning on the road, it's peeling out or whatever. In that case, the linear speed of the tire is faster than the linear speed of the car. But if the car is just driving along, the linear speed of the tire and the car are going to be the same. So first thing we need to do is find the angular speed of the tire, then we can find the linear speed of the tire. So the tire is rotating at 1,000 revolutions per minute. And we want to know what the angular speed is. Well, what we do is we multiply by 2 pi radians per 1 revolution. And that will give us radians per minute. So just mental math, 1,000 times 2 pi is 2,000 pi. And that's going to be radians per minute. Our revolutions here and here cancel. Now let's find the linear speed. Now all you need to do to find the linear speed is you take the angular speed and multiply that by the radius. So in this case, we're going to have 2,000 pi radians per minute times the radius, which is half the diameter, 1.15 feet. Okay, so if I multiply those two values, I'm going to get the feet per minute. (2,000) pi times 1.15, 7,225.7, let's say, feet per minute. Okay, now feet per minute, that is a valid unit for linear speed, but in terms of cars, I'm used to miles per hour. So I'm going to use unit analysis and convert. So we'll start with 7,225.7 feet per minute. I'm going to multiply that by 60 minutes per 1 hour. That's going to give me feet per hour. Then I need to change the feet to miles. So I'm going to multiply by 1 mile per 5,280 feet. So let's look at the setup here. 7,225.7 feet per minute times 60 minutes per 1 hour, and the minutes will simplify out there. And then I'm multiplying by 1 mile per 5,280 feet. Notice you have feet in the numerator here, feet in the denominator here. You're left with miles in the numerator, hour in the denominator. That's how you know it's going to be a valid unit conversion. So let me go to the calculator, and I'll multiply by 60, then divide by 5,280. Okay, so I have 82.1. I'm just going to say 82. So 82 miles per hour. Okay, that is the linear speed of the car. So let's review the process. First thing we did is we found the angular speed. And then we multiplied angular speed times the radius to get the linear speed, and that was over here in feet per minute. Then we converted feet per minute using unit analysis into miles per hour. So our car in this case was going about 82 miles per hour. And once again, one of the key ideas here is that the linear speed of the tire where it meets the road is the same as the linear speed of the car.